So, welcome again. This is another video that cover the summary that we did, but this one solves some problems. This is not enough problems to study. You should go back to the main lectures and see all the problems that we solved there, all the problems in the homework, all the problems that in the lecture notes, the PDF. So this is just to help you an extra problems that plus the problems that we solved in the lectures. So I'll start with some problems saying, for example, solve the following differential equation, and he's giving me square root of y dx plus 1 plus x dy equals 0, and he's also giving me an initial condition y of 0 equal to 1. So this is an initial value problem because he's giving me an initial condition. But first, this is definitely a first order differential equation, but it's not really written in the form that we would like to see. So the first thing I will write, divide every term by dx. So we could make it dy. So I'll divide here by dx. Sorry, divide here by dx. Divide here by dx. So this dx will go with this dx. So we'll have here square root of y plus 1 plus x times dy by dx equals 0. And then I can take the square root of y the other side. So dy, I mean, there is many ways we can do that, but this is one way. Dx 1 plus x here is equal to minus square root of y. Then I will possibly divide by 1 plus x. I mean, there should be actually an easier way than this, but it's okay. So dy by dx minus square root of y over 1 plus x. So now it's written like a first order differential equation. Now we can separate them, can get the dx here again in this side. So it will be dy equal minus square root of y over 1 plus x times dx. I can divide by square root of y. So 1 over square root of y dy equal minus 1 over 1 plus x dx. So now it seems to be like a separation or a separable differential equation. Actually, it was clear from here that it's separable, or from any of these steps that it's separable. Then we can go ahead and integrate both sides. So integrate. So in order to integrate 1 over square root of y, this is 1 over y to the power half dy equal minus 1. How to integrate that? We can say minus 1 times integrating 1 over 1 plus x dx. So we know that this is ln, and this could be written as y to the power minus half dy. So there is still an integration here, and this one minus ln 1 plus x plus a constant, and integrating this as we add 1 and divide by the new power. So y to the power minus half plus 1, so it's half, divided by a half, so it's multiplied by 2, equal minus ln 1 plus x plus a constant. So this is the general solution of our equation, but we have an initial condition that says y of 0 equal 1. So we go ahead and so we have y of 0 equal 1. This is x. This is y. So we remove every y and put 1. We remove every x and put 0. So 2 times 1 to the power half equal minus ln 1 plus 0 plus a constant. this will lead to 2 equal, this is 0 plus a constant, so C equal 2. So this is the constant. We can go back and substitute the constant here to get the final solution, which is 2 y to the power half, or 2 square root of y equal minus ln 1 plus x plus 2. You can go ahead and like make some adjustment here, but that's not really important for us now. So that would be sufficient. So this is one problem that we have here. A second problem could be, let me choose one good problem. So here, 1 over theta dy by d theta. So here just replacing x with theta equal y sine theta divided by y squared plus 1. So this is clearly again like, because everything is multiplied. So we could again multiply by theta first, and then do write it in the general form of a first order differential equation, and then start to separate. So let's do that. So here we do y by dx equal y over y squared plus 1. Let me write it this way: theta times sine theta. Can we do that? Yes, of course, we can. Now let's multiply by, sorry, this is d theta. Let's multiply by d theta. So here, dy equal y over y squared plus 1 times theta sine theta d theta. So it's almost separated, but we need to move this to the other side. So this will be y squared plus 1, because we go to the other side, will be flipped, divided by y dy equal theta sine theta d theta. We're going to integrate, because now it's separable. How to integrate that? Give yourself a try before you read the answer. Well, we can say this is y squared over y plus 1 over y whole dy. That's under the integration sign. And this integration here is integration by part. So in order to do this integration here, this will be u will equal to theta, dv will equal sine theta, du will be d theta. So we do the differentiation here. Here the v is minus cosine theta. And then that means integrating theta sine theta d theta equal this times this, which is minus theta cosine theta, minus integrating this times this. So it will be plus cosine theta d theta equal to minus theta cosine theta plus integrating of cosine sine theta. So this part here, we calculated here, so it's minus theta cosine theta plus sine theta plus a constant. So we have to put a constant in the whole equation. Here, I guess this y will go with this y, so we'll be left with y. The integration of that y is y squared over 2, plus this is ln y equal minus theta cosine theta plus sine theta plus a constant. And this is again the general solution. So this is again another separation of variable problem. It was easy to separate here, and we separated, and that was the solution here. Another problem. I guess that's okay. Determine whether this differential equation is separable or not. To give me some differential equations, and he's asking if it's separable or not. So for example, dy by dx minus sine x plus y equals 0. Is this separable or not? Well, it depends. If we can write this as a product, then it's separable. Can we write this as a product? Is there something in trigonometric identities that convert this to be a product? I guess there is. We have sine x plus y equals sine cosine sine. So sine x cosine y plus sine y cosine x. And in this case, even it will not be separable, because here sine and cosine, here sine and cosine. I don't think that this is separable, because yeah, it is not separable. Even if when we made this as a multiplication here, there is still a plus sign. Even if you take here, you can take sine as a common factor, or cosine as a common factor, because it's so it's not separable. Not separable. Another problem, say if it's separable or not. Dy by dx plus 4y squared minus 3y plus 1. Well, yeah, this is separable, because you can take just this as multiply by dx and divide by that. So it will be 1 over 4y squared minus 3y plus 1 dy equal dx. So separable, we can integrate both sides if we want to solve. But he's asking if it's separable or not. So this is for the separable differential equations. Let's see some problems on the linear first order differential equation. So it says here, solve the following differential equation. And it says here, t squared dx by dt, t squared dx by dt plus 3tx equal t to the power 4, then t plus 1. Well, this is a good problem. Is it linear? First of all, remember, like the independent variable is t and the dependent variable is x. So x, as it works as y in our standard form, and t works as an x. So is it linear? I guess yes, it is linear, but it needs some workaround. So we need to get rid of this t square, and it has 1x here, 1x here, plus, so everything is in place except this t square. So what we are going to do is to divide by t square. So here, this will be dx by dt plus 3 tx over t square, so it will be 3 over t times x, because when I divide here by t square, so this will go as this, so it will be only t there, equal t squared, then t plus 1 over t squared. Remember, every term has to be divided by t squared. Okay. All right. So this is now linear. The b of x is 3 over t. Q of x, sorry, now b of t and q of t is equal to t squared, then t plus 1 over t squared. Now we apply the two steps. First, number 1, find the integrating factor, which is mu of x, equal to e to the power integration 3 over t dt, which is e to the power 3 then t. Now, remember, we cannot remove the e and len at this current format. We have to take this 3 here. Why? Because we said that a len b equal len b for a, and the e and the len are inverse function if there is no factor here. So this means, or this will equal to e to the power len t cube. So that means our integrating factor, and this is t, equal t cube. Because now we can remove the e and len since they are inverse function to each other. So here we have our integrating factor. Can go ahead and apply the second step. So it's I times, or mu times, sorry, mu times x in this case, equal integrating mu times q dt plus a constant. And the mu, we just got it as t cube times x equal t cube times the q of x, which is t squared then t plus 1 over t squared dt. You can distribute this t. So this will be integrating t to the power 5 then t plus t over dt. Again, those are two integrations. This one, you should know that this is integration by part, and this is just a polynomial, so t squared plus 2. So you can take that and do it integration by part. We take u equal t, sorry, u in this case, because it's len, you will take the len t. The dv will be t to the power 5. In this case, the du will be 1 over t dt. The v will be t to the power 6 over 6. So this integration here, this part here, will be, which is integration t to the power 5 len t dt will equal to this times this, which is t to the power 6 over 6 then t, minus integration this times this, t to the power 6 over 6 times 1 over t dt. Here goes 1 over the 6, which is t to the power 6 over 6 then t, minus 1 over 6 integrating t to the power 5 dt, which is t to the power 6 over 6 ln t, minus 1 over 6 times 1 over 6 t to the power 6. And that leads to that the solution will be t to the power 3x plus, equal this the result of integration t to the power 6 over 6 then t minus 1 over 36 t to the power 6 plus integrating of this part, don't forget that, t squared over 2 plus a constant. And this is your final solution here. So this is one linear first order differential equation. Solve another problem. Okay, that's the last problem. So here we have sine x. The best thing in studying these problems is to just try to solve them yourself and then compare the answer. Plus y cosine x equal x sine x. So, well, this looks like a linear differential equation. Just has one y here, one y here. But the problem is that this sine x here, we need to get rid of this. So let's divide everything by sine x. So this will lead to dy by dx plus cosine x over sine x times y equal the sine x will go sine x equal x. So this is a very simple linear first order differential equation. This is our p of x. This is our q of x. So this is p of x. This is our q of x. So now let's find the mu. It's equal e to the power integrating p of x dx, which is equal to e to the power integrating cosine x over sine x dx. Well, how to integrate that? What is the derivative of sine x? Is cosine x. So this is e to the power ln sine x, which is the e and ln will go, so it's sine x. So that's your mu, or that's your integration function or integrating factor. Now we apply the second step, which is mu times y equal integrating mu times q dx plus a constant. Mu is just sine x times y equal integrating sine x, and q was, I guess, was x. Yes, was x. Yes. And again, we could do this easily using integration by part. All right. So those are very quick 3 problems. I might upload some other problems in the future. Thank you.